Hey, what's happening, guys? In our last video, we took a look at this Arduino Starter Kit from this company here called Muse. And the reason I picked this kit, as we talked about, is it came with this really nice little plexiglass experiment station, I guess you could call it. There's room for the 840 Type E breadboard, an Arduino Uno, and up here we have this 1602 LCD display. And that's what we're going to talk about today, how I got this working, because there are just a jumble of wires here. But when you really delve down into it and look deep into there, it's not that bad. Let's zoom in here, and we'll take a look up here at where the pins are labeled. And if you look at them, you can see we have VSS, which is ground, VDO, which is our plus 5 volts. Then here we have VO, which is a variable voltage. I've got it on this potentiometer here, and that controls the contrast here. Then we're going to skip a couple pins. We're going to come over here. We have D0 through D7, which is like an 8-bit parallel, but we're only using 4 of those: D4, D5, D6, and D7. And then over here on the end, we have A and K, which stands for anode and cathode of the backlight for the LCD display. And as I was talking there, looking for a screwdriver, hang on. There we go. Grab one of these here, big Clive style screwdrivers. And I just want to show you the effect here of the contrast. So if I turn it counterclockwise, you can see it's fading. It's fading. I can barely see it. But now I turn it clockwise. Nice and bright. I mean, look at that. And if I keep turning it, eventually we're going to end up with nothing. Whoops. But a set of blocks. Hang on here. This thing isn't behaving very well. Mostly because I'm just off kilter. But there you go. White blocks. So, with these little 16 by 2, that's what they're called, 16 by 2 LCDs, you definitely want to use a potentiometer here to set your contrast so that you have a nice readable screen. So let's talk about what a couple of those other wires are then. Alright, so we're back here looking at this again. We're going to talk about some of these other connectors up here. For instance, we have the RS, and RS is your register select. Register 0 is the instruction register. Register 1 is your data register. Next to that, we have this pin here, RW, which is read-write. And you just need to make it high to enable it to be able to read to it, or write to it rather. And E is your enable pin. So if we come back here and we have a look, E, our enable pin right here, is yellow. And I believe it is going over here to, yeah, Arduino pin 12. Have all of my grounds here. There are 1, 2, 3, 4 grounds. When hooking this up, you have to ground VSS, V0, which isn't really a ground, RW, and K. Those are all your grounds. And you have this 5-volt line here. If you look back here, we also have a 3.3 volt line that goes over to the backlight. So these can be a real mess. What's really nice is they also make these with an I2C backpack. So you only need power, ground, and data and clock wires. This is parallel, so it's going to be technically faster, but this is a pain in the butt to hook up. Also, from this Mazui kit, the male headers point straight down. That's just a bad idea. These were difficult to get in there. A 90-degree header with these sticking out the back is definitely where you want to go here. All right, let's get the basics of how this works out of the way so we can talk about how you can implement it. So the first thing you're going to need is to include the library. And this is the LiquidCrystal.h. Pretty much comes with all the Arduinos you buy, whether they're from the actual Italian Arduino company or from just some random Chinese company. You generally get this. Oh, never mind. What am I saying? It comes with the IDE. All right, so then we have these constant integers here, assigning a value of 12 to RS, 11 to enable, and then D4 equals 5, D5 equals 4, D6 equals 3, D7 equals 2. And then we have our constructor here, LiquidCrystal space LCD. So LiquidCrystal is our library. And then this is what we're calling it. We could call it anything we want. We could call it Jerry. We could call it Nancy. Doesn't matter. This is the library. This is what we're naming it. And then we have to tell it. Here is our register select, our enable, and here are our parallel data pins. So now we have this library set up with this name with these settings. So we need to tell it to start. In our setup section, we say lcd.begin 16,2. So what we're telling you here is 16 columns, 2 lines. Then we're going to tell it lcd.print. Remember, this name could be anything. It could be Mongo print. And then whatever we put in quotes is what it's going to print. This is just a little demonstration here. You'll see it in a minute. Then we say lcd.setCursor, leftmost position of the second line. And since the first line would be 0, 0, the second line is 0, 1. We print second line, we wait a second, and we clear the LCD. So here's a little demo you saw running at the beginning. This is our loop section. This will run over and over. Here's a little trick. If you want to know where these little curly brackets begin or end, select one, and it will show you the other one. So that's our entire loop section. This little section here is our for next loop. So we say for integer I equals 0. As long as integer I is less than 9,999, increment it through each iteration of the loop, and then lcd.print the variable I, wait a second, clear the display, and do it all over again. There are some other commands for this, including scrolling and things like that, but just to get you the basics here, this is what you need to know. lcd.begin needs to be in your setup. Before you get to the setup, you need your constructor, then you need your lcd.begin. Then to control it, where should you put the printer? Or where should you put the cursor? What do you want it to print? Clear the screen. Now we can actually do something. All right, so here's the demo I told you about. I'll reset it here. First line, second line. Then it just starts counting. And that's nice, but it's not very useful. So let's have a look over here at our different sensors and whatnots. How about the good old DHT11? That's not going to be terribly useful for us. That's all right. So our DHT11 we can just pick any where we want to put it, just like that. And now we're going to need some jumpers. Luckily this kit came with a whole bunch of these nice little DuPont type jumpers. I like the short ones. I don't like a bunch of wires flipping and flopping around. So, negative is this one. And we'll put that to our ground rail, which is the blue rail. Positive. Find a nice little red one here. Well, don't tell me I don't have any of these 4-inch red ones and they're all like 7 feet long. All right, fine. We'll use orange. See how you are. So that goes in there like that. And that goes up to our positive rail. And then we need one more wire, our signal wire. That goes to the signal here in the center. And then we can pretty much put this to any pin we want. Since we're using a lot of them, I think we'll use pin number 8. All right, let's go back over to the computer and I'll show you how I do this. A little cheat, I guess you could call it. Okay, let's make this work. So, we don't need any of this stuff here. But just for fun, let's do this. How many letters is that? 1, 2, 3, 4, 12, 13, 14, 15. Holy shit, that's 16. Yeah, we're full. Learn electronics. 1602, that's 4, 5. LCD, that's 8, 9, 10, 11, 12, 13. And what we'll do is give a little space there to kind of center a little bit better. We'll let this wait for 2 seconds before we clear the LCD. Now we're going to get into it. Here's the cheat. File, samples. I just have to find it. It's not there. Basics, no. Digital, no, you know. I found it. It's not listed as LCD, it's listed as liquid crystal, and if I paid attention to things like this, we would know, wouldn't we? So basically, yeah, we don't need any of that. What we need is DHT. There we go, DHT tester. Okay, so here's how I do this. Hang on, move this. So there is our one we're working on. There is our reference. And here's the first part of this video being burnt. I do it in stages. Okay. So, we know we need to include the DHT library. And we need to define our DHTPIN. Remember, in this case, we changed it to 8. So, 8. Then we need to tell it what type we're working with here. This is the DHT11. Then we need to initialize our sensor. And that's a constructor just like this one here. Name of the library is DHT. The name of the object is DHT. It is configured using DHTPIN and DHTTYPE. So down here in our setup, we'll begin our DHT. And then we can read our temperature and our humidity. So let's come down here and we'll start with lcd.setCursor. And we'll set it in the upper left position. And then we will grab temperature as Fahrenheit. Mistakey mistake there, huh? So there's our temperature as Fahrenheit. And then we can say lcd.print temperature colon I should put a space in there like that. And I colon say LCD. I don't think I have to set the cursor again, but I'll have to check. Print F. That is our temperature in Fahrenheit. And then we will say LCD print F for Fahrenheit. That should do the whole first line. So now we'll do the second line. LCD set cursor 0, 1. And then we can grab our humidity. You don't have to do them in this order. You could do all the grabs and then all the prints. I'm just doing it this way. Like you could actually see my hands moving as I'm gesturing. I'm just doing it this way as a kind of a flow of thought thing to make it maybe easier for you to understand. Okay, so we've set our cursor on the second line, and now we can say lcd.print relative for relative humidity. Then we can say lcd.print h and lcd.print %. And we're going to want to put a delay in there because you don't want to hit this sensor too many times. 1 second should be fine. We'll save it. All right, so now I am going to plug in the Arduino, which you may or may not have heard go boop, boop, boop. Make sure we're in the right place. Everything looks copacetic. And let's ship it. All right, our compile is just about finished. Of course, it's going to make me a liar now because it's going to slow down. Uploading. Hey, it works. But I bet you'd like to see that, wouldn't you? Yeah, I turned out the bright overhead, hoping we'll be able to see the screen better. And there we go. 74.48 degrees Fahrenheit, relative humidity 57%. Now, I understand that this is a super easy project, a very beginnerish project, but if you're new to this, this is exactly this kind of stuff you need to start with so you can understand the connectivity and the programming that goes to put this all together. But anyway, there you go. That's how you can make yourself a little digital thermometer. Could even dress it up, hang it on the wall, whatever you want. I hope you guys enjoyed this little project. And if you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. That's it. I'm out. Peace.